Hi, this is Sharon from SAS Statistical Programming.com. In this lecture, we're going to talk about how to reduce lengths for numeric variables. One way to reduce data storage space is to reduce the length of numeric variables. In addition to conserving data storage space, reduced length numeric variable use less I/O, both when data is written and when it is read. For a file that is read frequently, this saving can be significant. To store numbers of large magnitude and to perform computation that require many digits of precision to the right of the decimal point, SAS store all numeric values using double precision floating point representation. SAS numeric variables has a maximum length of 8 bytes and a minimum length of 2 or 3 bytes, depending on your operating environment. The default length is 8 bytes, and the minimum length for numeric variable is 2 bytes in mainframe environments and 3 bytes in a non-mainframe environment. In order to assign a length to numeric variable, we can use length statement to assign a length for 2 to 8 bytes to numeric variables. Remember, the minimum length for numeric variable depending on the operating environment. Also, keep in mind that the length statement affects the length of a numeric variable only in the output data set. Numeric variable always have a length of 8 bytes in the program data vector and during processing. This is the general form for length statement for numeric variable. Start with keyword length and followed by variables, and then followed by variable length, and then there's also a default equal option. The variables specify the name of one or more numeric SAS variables and separated by spaces. And length here is an integer that specifies the length of the variables. Default equals n option. This is optional argument. Change the default number of bytes that SAS uses to store any newly created numeric variables. If you use the default equal argument, you do not need to list any variables. Default equal option applies only to numeric variables that are created after the length statement. List specific variables and their lengths along with the default equal argument if you want the listed variable to receive a specific length. Then the non-listed variable receive the default equal option. Numeric values lose precision if truncated. This needs to be cautioned about. First, I'm using a proc import procedure to bring in an Excel data file, score data ID, and then the output SAS dataset is SD. Let's run this to have the data ready. This is the data SD. It has student name and 3 score variables, score 1, 2, 3, and student gender as well as student ID. In total, it has 11 observations. And then in the following program, I use the length statement to assign a length of 4 to the new variable that will be created, that is average score. This new variable is created by the min function to calculate the min for 3 score variables. Okay? Because in the length statement, I include this default equal option. So all the variables newly created will have this default length, which is 4, assigned to the newly created variable. The length statement in this data step does not apply to the variable that are already read from the input SD data set. Those variables will maintain whatever length they had in SD data. Okay, let's run this data step and then see what we got. This is the SD1 data set. We can see now we have a new variable which is average score. You can click on this and then then you can see the length for this variable is 4, which is the default equal option assign length 4 for this variable in the length statement. And also we can see for score 1, 2, 3, which are the 3 score variable that are stored in the input dataset, which is SD, the length for those 3 variables are 8. And the score 2 is 8, and also score 3 is 8 as well. Those are the default lengths for a numeric variable. Okay. Next, let's talk about how to maintain precision in reduced length numeric variables. So there is a limit to the values that you can precisely store in a reduced length numeric variable. We have learned that reducing the number of bytes that are used for storing a numeric variable does not affect how the numbers are stored in the program data vector. Instead, specifying a value of less than 8 in the length statement causes the number be truncated to the specified length when the value is written to the SAS dataset. You should never use the length statement to reduce the length of your numeric variable if the values are not integers. Fractional numbers lose precision if truncated. Even if the values are integers, then we should keep in mind that reducing the length of a numeric variable limits the integer values that can accurately be stored as a value. If you decide to reduce the length of your numeric variable, you might want to verify that you have not lost any precision in your values. So here's one way to do that. We can use this proc compare procedure to gauge the precision of the values that are stored in a shortened numeric variable. You do this by comparing the original variable with the shortened variable. So the compare procedure compares the contents of 2 SAS datasets. Select a variable in different datasets or variables within the same dataset. This is the general form for proc compare to compare 2 datasets. Proc compare and then followed by base equal SAS dataset 1 and then compare equal SAS data 2. SAS dataset 1 and SAS dataset 2 specifies the 2 SAS datasets that we want to compare. And the proc compare is a good technique to use for gauging the loss of precision in shortened numeric variables because it shows you whether there are differences in the stored numeric values, even if these differences do not appear once the numeric variables have been formatted. Okay. Again, I'm using another data step program. In this way, I'm creating a dataset called SD1 underscore. So basically, I copy previous dataset program, this data program creating the dataset SD1. I copy this program here, but I comment out this length statement. So when this average score variable is created, it will have the default length, which is 8. And then I will use proc compare procedure to compare SD1, which is created by this data step. So this average score will have a length as 4 with this dataset SD1 underscore. In SD1 underscore, this variable will have a default length as 8. Okay, let's run those 2 programs and see what we got. Okay, let's go to the output data first. This is the SD1 data set. And now let's look at this average score variable. And let's look at the length. The length for this variable is 8. And then let's look at the results. The results shows us the output from compare procedure. It shows the data set to be compared, and also shows number of observations with some compared variables on equal. It's showing there are 4 observations with unequal values. And also here, value comparison summary, number of variable compared with some observation on echo. There's one variable, and the total number of values which compare on echo is 4, and the maximum difference of those values are this number. Okay. And here also shows the variable with unequal values, which is average score. And lastly, it shows value comparison results for variables. You can see here it listed average score from base data set and average score from compare data set. It has different values, and also it listed the difference here, and also the values associated observations here. Okay, we can see because this variable average score has different lengths, so it calls the values for some of the observation are not equal. Some of the values are truncated because of the shorter lengths assigned for this variable. Okay. All right, this is it for this tutorial. This tutorial we talk about how to reduce lengths for numeric variables, and also we need to caution about maintaining precision in reduced length numeric variables. All right, thank you for watching. See you next time.